Hello everyone, my name is Chris McIntosh. I help teach the capstone courses. I wanted to go over how to describe and evaluate psychometric instruments you may use as part of your project. This presentation ended up being longer than I originally anticipated. Since this is being prepared for students creating quality improvement projects, I thought I would include a short version of what you should describe in your project proposal and manuscript here at the beginning. This slide will appear again at the end of the presentation. The rest of the presentation will go over concepts that will help you understand some of the language used here. A lot of the content for this presentation comes from this book. The text provides a short and practical guide on how to develop questionnaires. I was first introduced to this text during my PhD program, and I've used it through 3 editions. The latest edition is the best in my opinion. To understand the main point of this presentation, which is how to describe and evaluate psychometric instruments, we need to understand a few terms and concepts. Measurement is foundational to science. We use it to do categorization and scaling. Measurement is assigning numbers according to rules. Each area of science develops measurement tools and procedures. All measurements are subject to error. Random errors are due to chance and don't have a pattern. You can see in this image, darts are all over the place. Systematic errors are due to some kind of process. There's often a pattern present. You'll see in this example, the darts are clustered, but they're not hitting the bullseye. We may be measuring directly observable phenomena like height and weight. There's a field of science dedicated to measurement called metrology. We may be measuring non-physical phenomena that we can't directly observe. Those may be things like knowledge, emotions, preferences, theoretical constructs like IQ or anxiety or depression, and many other things. Psychometrics is a field of science dedicated to measuring psychological and social phenomena. It is a subspecialty in behavioral and social science. Just like there are tools for making physical measurements, there are tools for making psychological and social measurements. They are used to measure phenomena believed to exist but which can't be directly observed. They use a collection of items combined to create a composite score. These are often made up of multiple questions. They're called composite measurement tools. The phenomena range from the fairly concrete to the abstract. There are 3 main types of composite measurement tools: scales, indices, and logical groupings. We'll talk a little about each one. Scales are grouped items that are theorized to have a common cause. The cause is a theoretical construct that may not be directly observable. Scale items are observable proxies used to measure the construct. See the arrows point from the theoretical cause to multiple items. Examples of scales might be IQ scores, anxiety scores, or depression scores. Indices are grouped items that are theorized to result in an effect. Grouped items may not be necessarily related to each other. The aggregate score comes from an index, often provides an overall picture. Examples of indices are stock indices, APGAR scores, or Glasgow Coma scores. Some groups of items aren't necessarily a scale or an index. There's usually a theory behind a scale or an index. However, groups of items are sometimes made based on logical categories. Groupings of this type are atheoretical and may or may not necessarily be useful for a given purpose. It can be difficult to know if an instrument is a scale, an index, or neither. There are a number of reasons why this is the case. Theorizing about causes and effects is not straightforward. There is a lot of room for interpretation and error. Also, there is wide variability in how much training researchers receive regarding instrument development. Instrument developers may not have been trained about the differences between an index and a scale. Adding to the difficulty is the terms scale and index and instrument are often used interchangeably. The understanding and language surrounding these tools has evolved over time. Some instruments may not fall clearly into the category of a scale or an index, but may demonstrate characteristics of both. Here are some ways to try to tell the difference. Scale items usually share an underlying cause. Scale items are often interchangeable. Responses to one item may help predict responses to another item. Scale items often tap characteristics of the respondent, and there's often high correlations between scale items. Index items often don't seem to be related. Index items are usually not interchangeable. Index items are often not predictive of one another. Items are typically tap characteristics that are external to the respondent, and there's often low correlations between items in an index. Now we'll discuss how to evaluate instruments. These are things to keep in mind as you learn about the instruments you consider using in your projects. Not all composite instruments are created equal. Often, differing levels of knowledge, care, and attention to detail were used when instruments were created. Some developers may not fully consider if instrument items result from a common cause, or if instrument items combine to result in a common effect, or if the items are just a convenient category to create a group. It is up to you to evaluate the instruments you use in your projects. Next, we're going to review important information to understand when evaluating scales and indices. The two main things we'll look at with both of them are reliability and validity. Reliability in this context means consistency. Are you getting consistent results with your measurements? The target on the left demonstrates consistency. It doesn't always necessarily mean you're hitting the mark, though. Validity in this context means accuracy. Are you measuring what you intend to measure? Are you hitting the bullseye? The target on the right demonstrates validity. Some would argue that to really have validity, you must also have reliability. I fall into that camp. Now we'll discuss some considerations when evaluating scales. The purpose of a scale is to measure an underlying theoretical construct. The underlying construct is presumed to be the cause of the observable variables. Sometimes the underlying construct is called the latent variable. Mathematical procedures are used to evaluate how well observable variables estimate a latent construct. Some procedures used are called exploratory factor analysis, confirmatory factor analysis, and item response theory, or IRT. Evaluating reliability is one important way to evaluate scales. Reliability in this context means consistency. Reliability is not a property of a scale. It is a property of the use of a scale. You often hear this misstated and written incorrectly. You shouldn't be asking if an instrument is reliable, but you should be asking if a particular use of a tool yields reliable results. One common type of reliability examined for scales is internal consistency reliability. This type of reliability measures how well items in the scale relate to each other. This type of reliability is called Cronbach's alpha. Cronbach's alpha is the average correlation between all the items in the scale. Correlations range from absolute value 0 to 1. Higher scores for Cronbach's alpha means there is higher internal consistency. A Cronbach's alpha from 0.7 to 0.9 is ideal. One limitation of Cronbach's alpha is it is affected by the number of items in the scale. The more items in the scale, the higher the Cronbach's alpha score will be. Scales with a lot of items, more than 7 to 9 items, may have an artificially inflated Cronbach's alpha score. As a side note, coefficient omega is a proposed alternative to Cronbach's alpha, but it is not widely adopted. There are other types of reliability that can be evaluated with scales. Again, these are reported as correlations, so scores range from 0 to 1, with higher scores being better. Alternate forms reliability measures how strongly different forms of a scale designed to measure the same construct relate to each other. An example of alternate forms might be different version of a math test, testing the same type of concepts but using different actual questions. Inter-rater agreement measures how closely different raters give the same score using the instrument. Temporal stability, also known as test-retest reliability, looks at how consistent scale results are over time when a scale is used repeatedly. Evaluating validity is another important way to evaluate scales. Validity means measuring what you intend to measure. Validity is not a property of the instrument. It is a property of the use of an instrument. This distinction is often misstated. An example that illustrates this distinction is using a scale written in English with non-English speakers. The scale may be fine, but the use of the scale is totally invalid in that context. There are many ways to consider validity, but 3 common validity evaluations are called content validity, criterion-related validity, and construct validity. I'll briefly describe each of these. Content validity assesses if scale items measure the construct of interest. Are scale items representative of the concept domain? The ability to evaluate content validity depends on how well the concept of interest is defined. Content validity is usually assessed by evaluating the steps the scale developer used when creating the tool and if there was external expert review of the items that make up the scale. Assessing content validity often looks at if formal procedures were used to evaluate content validity of the scale and how rigorous those procedures were. Criterion-related validity assesses how a scale compares to a gold standard. This is often calculated using a correlation between the scale and the standard. This may be relevant in instances where the gold standard measurement is difficult or expensive to obtain, but using a scale may be easier, cheaper, or quicker. People will be interested to know how results from the cheap, quick method compare to measurements from the expensive, difficult method. Another way to evaluate the validity of a scale is by examining construct validity. Construct validity examines the theoretical relationship of a variable to other variables. Construct validity measures how the observable variables of a scale relate to the theorized latent variable. This is often examined using mathematical procedures called exploratory and confirmatory factor analysis. Sometimes correlations with another known construct are also calculated. Now we'll discuss some considerations when evaluating indices. The purpose of an index is to measure multiple items which combine to produce a theorized effect. There are 2 main types of indices. Indices where index items may be conceptually related, and indices where index items may not be conceptually related. Indices with conceptually related items may be developed based on an underlying theory. Indices where items are not conceptually related may just be empirically useful. Certain types of reliability may be relevant to indices. Because index items do not share a common cause, index reliability should not be evaluated using internal consistency reliability or Cronbach's alpha. Cronbach's alpha is probably the most common type of reliability examined with scales, so many individuals often expect to see it used with indices as well. However, inter-rater agreement and temporal stability are types of reliability that are applicable to indices. See the previous section for a fuller description of those types of reliability. Validity for indices can also be examined in certain ways. Content validity is relevant for indices. Index items can be evaluated by experts to ensure domain representation. Criterion-related validity is relevant for indices. Index scores can be compared to a gold standard for empiric evaluation. Because indices are not developed using factor analysis, construct validity is irrelevant. We'll review some questions that are good to answer when writing about and evaluating instruments. The first question to answer is, what type of instrument is it? Is the instrument a scale, an index, or not well defined? This will determine the appropriate information you should evaluate and report about the instrument when you use it in your project. Here are some questions to answer regarding background information for scales. Is the construct of interest well defined by the instrument developers? What is the definition? Was a theory used as part of instrument development? What theory? Does the instrument have any subscales or just generate an overall score? What are the subscales? Are any published reliability estimates available? What are they and how were they obtained? Are any published validity evaluations available? What are they and how were they obtained? Is the use of this instrument appropriate in this context? Was it designed to be used with this population and for this purpose? Is this the best instrument for this purpose? Why? Are there better alternatives? What are they? Here are some questions to answer about how a scale is supposed to be used. What is the mode of administration? Is it paper or verbal or electronic? How many items are used in the instrument? How are items on the instrument rated by users? What type of scaling is used? Is it Likert scaling, semantic differential, visual analog, pictorial, numerical format? How is the instrument scored? Is any reverse coding needed? Are there any published standards or norms for the instrument, or what scores on the instrument indicate? Can a copy of the instrument be included in your publication? Here are some questions to answer regarding background information for an index. Is the construct of interest well defined by the instrument developers? What is the definition? Was a theory used as part of the instrument development? What theory? Are the index items conceptually related to each other, or are they diverse, unrelated items? Conceptually related items may indicate a unifying theory was at the heart of index development. Are any published reliability estimates available? What are they and how were they obtained? Are any published validity evaluations available? What are they and how were they obtained? Is the use of this instrument appropriate in this context? Was it designed to be used with this population for this purpose? Is this the best instrument for this purpose? Why? Are there better alternatives? What are they? Note, because index items do not share a common cause, they are not developed using factor analysis, and they should not be evaluated for internal consistency, reliability, Cronbach's alpha, and construct validity would be irrelevant. Here are some questions to answer about how an index is supposed to be used. What is the mode of administration? Paper, verbal, electronic, or something else? How many items are used in the instrument? How are items on the instrument rated by the user? What type of scaling? Likert, semantic differential, visual analog, pictorial, numerical format, or something else? How is the instrument scored? Is any reverse coding needed? Are there any published standards or norms for the instrument, or what scores on the instrument indicate? Can a copy of the instrument be included in your publication? Now we'll discuss some important points to consider when writing for publication. We're back at the slide I showed at the beginning. Hopefully it makes more sense. I'll reiterate the points. Here are the items you should include in your project proposal and manuscript when describing an instrument you're using in your project. A description of the instrument and summary of the psychometric properties is usually included in the methods section. The purpose of the instrument, definition of key terms, constructs, number of items, answer format of items, scoring, validity and reliability, target populations and use cases, and a short evaluation of the suitability of the instrument for how it was used in the project. Here's a note about copyright if you're going to publish your manuscript. It is often useful to include a copy of the instrument, or at least its content, in the appendix of a paper. Copyright permission should be obtained to do this for publication. The copyright holder is usually the journal that first published the instrument and not necessarily the instrument developer. Here are the references.